Good morning. Welcome to online lesson 4. Today we're going to be talking about the importance of the unit circle. Remember to take your notes, pause when necessary, replay when important. This is a summary of the unit circle. Super important for us. Usually we would memorize this year. We're not going to memorize it, but you need to be responsible for being able to use it. The biggest thing that we want to think about with the unit circle is that in every single one of these points, each of these spokes on the unit circle has a radius of 1. In our previous lesson, we talked about how we could convert degrees to radians. When using the unit circle, we go counterclockwise for positive degrees and clockwise for negative degrees. You should be able to understand any degree or radian measure along this unit circle and be able to convert appropriately. These are the coordinates of where this would belong if I put this on an xy axis, where this is 0, 0. This point here would be root 3 over 2, 1/2. All of these numbers along the outside of the unit circle come from applying special right triangles, either a 45, 45, 90 triangle or a 30, 60, 90 triangle on a function with a radius of 1. As we get started today, we're going to talk about what is sine, cosine, and tangent relative to our unit circle. So when we first get started and start to think about this, we can think about the fact that this has, again, a radius of 1. Your horizontal distance is x, vertical distance of y, giving you this coordinate of x, y. It's important for us to understand what those coordinates represent. So let's start by calculating sine. Sine of theta is our opposite over the hypotenuse. Cosine of theta is adjacent over hypotenuse. Tangent of theta is opposite over adjacent. When we look at all of those, that means that this point represents the cosine and the sine without having to do any further calculations. We can find the other 3 ratios by taking these reciprocals. So the reciprocal of sine is cosecant, so that would be 1 over y. The reciprocal of cosine is secant, so that would be 1 over x. And the reciprocal of tangent is cotangent, that would be y over x. All of these should be done by hand and calculated based on these points on the unit circle. We should not need our calculator for any of these calculations. So when we look at this and we start to think about where would this 6 trig ratios be on a unit circle, we want to start thinking about first, what is that coordinate? So for this coordinate, this is the point, root 3 over 2, 1/2, to get us to that point of root 3 over 2, 1/2, as we see it on the unit circle. Sine, again, is your y value, so sine would be 1/2. Cosine is your x value, so this would be root 3 over 2. Tangent is a little more complicated. Tangent is y over x, which would require us to cross multiply. And rationalize your denominator. Now to find our reciprocal ratios, we flip these fractions. This one requires us to rationalize. This becomes 2 root 3 over 3. And then our last one, we start with root 3 over 2 divided by 1/2. This time when we flip, the 2's go away and we just get root 3. Those are our 6 exact values for 30 degrees. Again, we're all going to be using the unit circle to help us find those exact values. So on this, we have the radian measure of 2 pi over 3. So we're going to locate 2 pi over 3 on our unit circle. Then we're going to look at what ratio we're trying to find. We're trying to find the sine ratio, which is our y value. So that ends up giving us root 3 over 2. For tangent of negative 45 degrees, again, negative means we're going around the circle clockwise to get that negative degree. So 45 degrees would be pi over 4. So negative 45 degrees would be the same spot as 315 degrees. This time we're finding the tangent, and our tangent ratio, as we previously found, was y over x. So we need to do our y value divided by our x value. Dividing a fraction, remember you flip and multiply. And everything cancels out, leaving you with -1. Secant is not on our unit circle, so we need to find the comparable piece of secant. Remember that secant and cosine go together, so we're actually going to find cosine of 5 pi over 3. So let's look in our unit circle for 5 pi over 3. We want cosine, which is our x value. But because originally we were finding secant, we're going to do 1 divided by that cosine. Again, flip and multiply, and you get 2. 3 more examples for us. Again, these ones are not always going to be found on our unit circle. For the first one, we want to find cotangent of pi over 2. Cotangent is the reciprocal of tangent, so we're going to find pi over 2 on our unit circle. Tangent would be y over x, so cotangent is x over y. So when we look on our unit circle, we're going to do x divided by y, which is 0. The next example gives us cosine of 7 pi over 6. So we're going to find 7 pi over 6, and we want the cosine, which is our x value. Let's remember that in quadrant 3, everything is negative, so this is negative root 3 over 2. On our last one, we have cosecant. Again, cosecant is not going to be on our unit circle, so we need to find the reciprocal of this, which is sine. Negative pi over 4 means we're going clockwise around the circle. Pi over 4, which is 45 degrees, we're going to be here. The sine of that is my y value, so the sine of that is negative root 2 over 2. So if I want to find the cosecant, I need to do 1 divided by negative root 2 over 2. Again, we're going to flip and multiply. That puts the 2 on the top and the radical in the denominator, which then needs to be rationalized to give us 2 root 2 over 2, which then gets reduced to just negative root 2. Again, you're not going to have to memorize the unit circle this year. You just need to be able to use the unit circle. So far, our examples have used the angle in radians or degrees to find the coordinate point. This is going to ask us, starting at the coordinate point, to find the angle that would allow us to have that increment. So for example, when we look at question 1, sine is a y value. So we're looking for a y value of root 2 over 2. Looking at the unit circle in quadrant 1, this appears when theta, or t, equals pi over 4. If we look on here, we're going to find 3 other points that are similar, either plus or minus. We can see that in quadrant 2, this is going to show up when theta equals 3 pi over 4. And in quadrant 3, it's going to show up when t, or theta, equals 5 pi over 4. And in quadrant 4, it's going to show up at 7 pi over 4. These two are negative, and these two are positive. For second example, we want to find cotangents. Let's remember that cotangent is x over y. So we're looking for the angle in which the ratio of x over y is root 3. Another way you can think about that is you're looking for theta with inverse tangent equals 1 over root 3. Again, you can take the reciprocal of cotangent and the reciprocal of your ratio. This is going to happen in quadrant 1 when theta equals pi over 6. In quadrant 2, you're going to have negative root 3 over 3 at 5 pi over 6. In quadrant 3, it's going to show up at 7 pi over 6. And in quadrant 4, it's going to show up as 11 pi over 6. Again, 2 are positive. In this case, it's quadrant 1 and 3 that are positive, and quadrant 2 and 4 are negative, root 3 over 3. Here, it's unrationalized, but we can always rationalize. Again, here's another example of what this would look like. Looking for solving for our value of t. In order to solve for an angle, we are going to take the inverse sine of our ratio, and that's going to tell us what that angle is. For the first question, once it's defined it in quadrant 1, so I'm going to look for a y value of 1/2, and that happens at 1/2 happens at pi over 6. So t equals pi over 6. From the symmetry we know about a unit circle, everything is going to show up on the unit circle twice. We're going to have 2 positives and 2 negatives. So I'm going to find the second place where my y value is positive 1/2. And that gets me to an answer of 5 pi over 6. So if I want to find all values between 0 and 2 pi, I would write my answer as pi over 6. That's what happens in quadrant 1. And then I would write my answer as 5 pi over 6. That's where it happens the second time. For the third question here, when it wants us to find all real values, remember that this is a circle and continuous, and we can go around the circle as many times as we want. If we start here at the beginning, one revolution would be 2 pi. Going all the way back around again would be 4 pi, 6 pi, 8 pi, so on and so on. So we want to be able to list this answer not just for where it shows up in one circle, but where that shows up every single time that I write that answer. This is going to be a unique way to write the answer. You're going to write t equals pi over 6 plus 2 pi k. Then you're going to have a second answer of 5 pi over 6 plus 2 pi k. Now this is a unique way. We haven't done anything like this with this ending of a k. K is going to represent all real revolutions. So we're talking about multiple times around. So we're going to start here and go all the way around to the next time this value happens. And then all the way around to the next value it happens, kind of like we were finding on the spiral for the extended learning assignment number 1. Because those two values are not symmetric on the unit circle, we can't go from one to the other taking the same number of steps, the same leap. We have to write both answers separately. Let's look at a second example of that. Again, this time we're going to find cosine of t equals negative pi root 3 over 2. So really what we're looking for here is inverse cosine of negative root 3 over 2. Remember that cosine is a x value, so we're going to be finding an x value that gives us negative root 3 over 2. Looking at my unit circle, that shows up here and here. So I'm going to write my answer. Let's see what type of question it wants me to talk about. First, it wants me to find where the value is in quadrant 3. So we're going to start at that x value and go backwards to the radian measure. Therefore, t would equal 7 pi over 6. If I want to show all places where this is equal to negative root 3 over 2, I would list my answer as 5 pi over 6 and 7 pi over 6. If I want all real values, this is what I'm doing, multiple revolutions, and I have to add the ending to make it go for all real numbers. So theta equals your first answer, which is 5 pi over 6, plus 2 pi k, and then theta equals 7 pi over 6 plus 2 pi k. Again, that k at the end is a variable representing that multiple revolutions. Every time I go around the circle, make one full loop, I'm going to get to 2 pi. Let's look at this one here. We want to find secant of t equals 2 root 3 over 3. We can see right away that this number has been rationalized. This solution, without being rationalized, would have been 2 over root 3. Let's use that. Secant is not on our unit circle, but its reciprocal is, so the reciprocal of secant is cosine. And if I'm taking the reciprocal of the left, I have to take the reciprocal of the right. So what I'm doing as I'm solving for t is I'm finding the inverse cosine of that ratio of root 3 over 2. Remember that cosine is an x value, so I'm going to find where is that x value, root 3 over 2, on my unit circle, and then look at what the question is asking. The first question is asking for where is that radian measure in quadrant 1. So t equals pi over 6. When it asks for all real values between 0 and 2 pi, again, this is one revolution. Where does it show up in one time around the circle? My answer would be pi over 6 and 11 pi over 6. When I want all real values, this is many or multiple revolutions. I have to add that weird ending, t equals pi over 6 plus 2 pi k, and t equals 11 pi over 6 plus 2 pi k. Let's look at one more here. This time we're looking for tangent of t equals 1. Again, we're solving for t, so we're looking for inverse tangent of 1. I know that tangent is going to equal 1 when both my x and y value are the same. So here it's going to equal 1, and here it's going to equal 1 because both my x and y value are the same. If I divide y by x, I get 1. So if I want to know where that is going to be in quadrant 1, I write t equals pi over 4. If I want to know where those all fall between 0 and 2 pi, again, this is one revolution around your unit circle. You would list both solutions, pi over 4 and 5 pi over 4. Now, a difference that I note for this question versus the previous question is these are two values that are symmetric on the unit circle. They are exactly pi radians apart. I can go from one answer to the next answer evenly by just walking forward by pi units. So when I write my answer for all real values, again, this is many revolutions, the ending is going to change slightly. I'm going to write this as pi over 4 plus pi k, and I only have the one answer because this is showing how far from one solution to the next. They are only pi radians apart. That k would represent either one time, a second time, a third time as I continue to go around the circle. Now that we've completed this, you want to do the WAMAP assignment that goes with lesson 4.